Hello students, this is your Shiva and you are watching Shiva's Maths Library. In the previous video, we saw the end of the chapter exercise for first chapter, and that is for the first three questions. In this video, we are going to solve the next three questions. Let's start with our fourth question, that plot the point z 5 comma minus 6 on the Cartesian plane. Construct a right angle triangle IZN and find the length of each side. That is, find the length of the three sides of the right angle triangle IZN. First of all, we have to start our question with the first point of plot the point z of 5 comma minus 6 on the Cartesian plane. So we have taken a Cartesian plane here, and the point is z 5 comma minus 6 as the x coordinate as 5. So x coordinate is 5 here, and y coordinate is minus 6, which is located on the downside of y axis. So this could be our point 5 comma minus 6. Our first part is over, and this is the point Z. Now our work is to select two more points called I and N, so that the triangle IZN should be a right angled triangle. Here is our important point. You know the point Z. I have to select two point I and N so that the triangle should be a right angle triangle, right? So what is the concept of right angle triangle? One of the angles should be 90 degree. Here I am going to fix the point Z as an second middle point, and I am going to consider two straight lines which are perpendicular to each other, so that the triangle should be a right angle triangle. For that I am going to use the basic idea of Cartesian plane, that here y coordinate and x coordinate, these two lines are perpendicular to each other. Suppose if you are taking any line which is parallel to y axis and parallel to x axis, those two lines also perpendicular to each other. For example, if I am going to consider a line segment like this which is parallel to y axis, and again I am going to consider a line segment which is parallel to x axis somewhere here or here. Here this is parallel to x axis. See the angle made by these two lines, they are perpendicular to each other. So based on this fact, what I am going to do here is I am going to select two lines, that is I am going to draw two lines from the point Z, that is parallel to x axis and parallel to y axis. So first I am going to draw a line Z which is parallel to x axis, okay, and another line which is parallel to y axis. Okay, now the thing is clear that the angle made by these two lines are perpendicular to each other. Next thing is, to find the length of the three side, we have to choose the end points of this line, because the points are not ended here, it can be extended up to any direction, okay, up to any length. Here I want to, for an easy purpose, I want to extend this till my y axis line, and this line up to my x axis point. Now if you join the remaining 2 points, it will form a right angle triangle, where I can say that this is my point I and this is my point N. So IZN is a right angle triangle, where the coordinates of the point I nothing but it's located on the x coordinate value of 5 and y coordinate as 0, as it lies on the x axis. Similarly, the coordinate of N are minus 6, sorry, it should be 0 for x and minus 6 for y. So these are the three coordinates of this triangle IZN, which is a right angle triangle. Now we need to find the length of the three sides, right? So for that, let's consider the first side of IZ, length of three sides, and the sides are, first is IZ, and look at the points I and Z. They are located on the same straight line which is parallel to y axis, where your x coordinate is same, 5 and 5. We just need to find the length of this line, which is nothing but it starts from 0 and it ends at the 6. Okay, here we are writing it as minus 6 because it's located on the negative side of y axis. That's why we have written it as our minus 6, but actually it should be 6 units. So to find this value, we are subtracting the coordinates of 5 and 0 and minus 6, so it has to be 6 units. So length of IZ is 6 units. and the second one is length of Zn, length of Zn. If you consider the coordinates here, you can find the difference that there is a change in the x coordinate. Here it is 0 and here it is 5, but y coordinate are same, -6 and -6. So in the same way we are going to measure this length where it starts from 0 and it ends up with 5 here. So this length has to be 5 units. So the length of Zn is 5 unit and Iz is 6 units. Now the only thing is how we are supposed to find this length, that is the hypotenuse of the right angle triangle, that is In. Since we know the length of other two sides as 6 unit and 5 units, and also the triangle IZN is a right angle triangle, by Pythagoras theorem we can able to find the value of hypotenuse. Okay, so by considering Pythagoras theorem, Pythagoras theorem we know that In square is equals to Iz square plus Zn square. Square of hypotenuse is equal to sum of square of other two sides. So Iz square must be 6 square 36 plus Zn is 5 square 25, which is equals to 61. So In square is equals to 61. This implies that In is equals to plus or minus root of 61, where In is the length of the side of the triangle, so it may not be negative anymore, only positive values are accepted. So the answer is 61 units. Hence In is root 61 units. Okay, the next question is, what should be a system of coordinate be like if we didn't have a negative numbers? Would this system allows us to locate all the points on the two-dimensional plane? So here they're supposed to ask two questions. In the first question, what they are trying to ask is, what would be a system of coordinates be like if we didn't have a negative numbers? Consider this coordinate plane. Actually here we are having positive side of x-axis, negative side of x-axis. Similarly for y-axis, positive side and negative sides are there. Suppose if I am removing this negative side of x-axis, which means this part is removed, there is no negative numbers. Similarly on y-axis, I am going to remove this negative part. Okay, if this side is not available, then I can't able to plot any value above this negative side of x-axis and also below this negative side of x-axis. So this is also not possible, this is also not possible to plot. And consider the negative side of y-axis. Similarly right and left hand side of negative side of y-axis are not possible. So already it is not possible for x-axis. Now consider the right hand side part, this is also not possible, which means I can able to plot the points only in the first quadrant where both x value and y values are positive. So the question is, what would be a system of coordinate be like if we do not have a negative numbers? So the answer for this is, the system would have only one quadrant, and that is nothing but x greater than 0 and y greater than 0. If we don't have a negative numbers, then there will be only one quadrant, that is first quadrant of first quadrant, where both x greater than or equal to 0 and y is also greater than or equal to 0. So this is what will happen. And in the next question, would this system allows us to locate all the points on the two-dimensional plane? So here itself we can able to say that since we don't have any negative value and in this system we are having only positive value, we can't able to substitute any negative number coordinates. Okay, suppose for example, if the coordinate is -2 comma 5, okay, where our x coordinate is -2 here, since we don't have negative numbers we can't able to access this negative side of x-axis, and the point 5 is located above the x-axis, so it has to be here. Minus 2 comma 5 should be here, but since negative sides are not possible here, we can't able to plot any point which contain a negative coordinate. Either an x coordinate contain negative number or y coordinate contain a negative number, or both. We can't able to plot those points. So would this system allows us to locate all the points on the 2D? The answer is no. This system doesn't allow us to does not allow us to locate all the points, all the points. Only first quadrant is accessible. That's all. So only first quadrant is accessible. The next question is question number 6, and here are the points m minus 3 comma minus 4, a 0 comma 0, and g 6 comma 8 are on the same straight line. Suggest a method to check this without plotting and joining the points. Actually, the second thing is very easy. We know that in our coordinate, it is easy for us to draw the Cartesian plane and plotting the given points. Okay, this is our Cartesian plane, and when we are plotting the point m, which is minus 1 minus 2 minus 3 and minus 1 minus 2 minus 3 minus 4. So this is our point m, which is minus 3 comma 4, and the point a is our origin 0 comma 0, and the next point is g 1 2 3 4 5 6, and here it's 1 2 3 4 5 6, and this must be 7 8. So here the next point is 6 comma 8. Now I'm assuming the point has to be here, the point g 6 comma 8. Now if I join these 3 points, it is clear that the 3 points are lies on the same straight line. But the thing is, suggest a method to check this without plotting the point and joining, without plotting and joining the point. If we plot the point, it is easy for us to identify they are lies on the same line. Now we need to show that these 3 points are lies on the same line, okay, by using different method, and the method now we are going to follow is called the method of collinearity. The method of the method of collinearity. Okay, so we have two things. One is geometrical meaning. The geometrical meaning of collinearity is the point A, B, and C are lies on the same line, are lies on the same line if AB plus BC equal to AC, or AB plus AC equals to BC, or BC plus AC equal to AB. Suppose if we have 3 points A, B, C which are lies on the same line, then it has to satisfy any one of the 3 conditions, such that AB length of the 3 sides, that is AB, BC and AC. Since we are having 3 points, we can able to find AB, BC and AC. Sum of any 2 points should be equal to the third one. Then we can say that the points are lies on the same line. So we are going to use this method of collinearity to show that the points lies on the same line. Okay, so here we need to find the distance AB, BC and AC. Then we will see whether the sum of which two is equals to the third one. So here first we will find the distance for M and A. So M is minus 3 comma minus 4, m is minus 3 comma minus 4, and the point A is 0 comma 0. Now I need to find the distance between m and A. So for that we have a distance formula, that is nothing but under root x1 minus x2 whole square or x2 minus x1 whole square. Most probably we should use x2 minus x1 whole square, but this is also correct, so no issues. So x1 minus x2 whole square, y1 minus y2 whole square, where my x1 y1 is minus 3 and minus 4, and here x2 y2 is 0 comma 0. So the distance MA is equals to under root x1 minus x2, minus 3 minus 0 whole square, and minus 4 minus 0 the whole square, minus 3 square plus minus 4 square, and we know that minus 3 square is 9 and minus 4 square is 16, and sum of 9 plus 16 is 25, which is equals to 5 units. So we found the distance MA. MA is 5 units. Now we need to find the distance of AG. Okay, and the point A is 0 comma 0, point G is 6 comma 8, right? Okay, so let's see. So AG is equals to same under root, the point A is origin, and the point G. A is origin and the point G is 6 comma 8. So x1 minus x2 plus y1 minus y2 the whole square. Again it will be minus 6 square and minus 8 the whole square, which is 36 plus 64, nothing but root 100, which is equals to 10. This is our AG. Okay, so we found out the value of MA and AG. Now the third side is MG. We need to find the third side, where the point M is minus 3 comma minus 4 and the point G is 6 comma 8. So minus 3 minus 6 the whole square and minus 4 minus 8 the whole square. So this is minus 9 square and this is minus 12 square, which is equals to 81 plus 12 square is 144, which is equals to 225, and under root 225 is 15, and we found the value of mg as 15. So from these three values we will get a clear picture that MA is 5 units, AG is 10 units, and this is 15 units. So out of the three, sum of any two should be equal to the third one. So here it is clear that if I add 1 and 2, I will get the value of 3. So MA plus AG is equals to MG. This implies that MA and G lies on the same line, same straight line, same straight line. That's all. Okay, so the method is very easy, and this method is called as method of collinearity. Moreover, in many of the places we are supposed to use this method to show that the 3 points are collinear.